Hi, I'm Brianna Brown and I teach pre-cal and geometry at Temple High School. Today we are going to be talking about simplifying radicals. And when we talk about simplifying radicals, we are breaking them down to where we have the most simplified numbers we can use. We're using prime numbers. So prime numbers are numbers that can only be divided by 1 and the number itself. So some examples are 1, 2, 3, 5, and then there are multiple others that you can look up. So just for our sake, we're going to write down 1, 2, and 3. So these are just some examples of prime numbers. And like I said, there are plenty more that you can use. So we're going to look at simplifying a radical to where we are able to use those and still have the radical there or not there, but to where we are simplifying with those numbers. So our first example, we are going to simplify radical 72, which is also known as the square root of 72, because we could have a different number than 2 here. So this is the same thing as square root of 72, because we could replace this 2 with a 3 and have it be cube root and different ones like that. So here we want to break it down. I'm going to show 2 ways of breaking the square root of 72 down. So one way is breaking it down inside of the radical. And this symbol is called our radical. So we want to know what we can multiply together to get 72. So our factors, in other words. And we want our factors to be prime numbers. So it may take a little bit doing it this way. But we know that 2 times 36 is equal to 72. And we want to break that 36 down a little bit more to where we get 2 times 3 times 12. Now we have 2 prime numbers, but this 12 here is still not prime. So we need to break it down a couple more times to where we have radical 2 times 3 times 3 times 4. Now we have 3 prime numbers and we just need to break down this 4 one last time to where we have radical 2 times 3 times 3 times 2 times 2. So now that we've broken it down completely to where we only have prime numbers, we're getting pairs of numbers and pulling them out. And so we have 1 pair of 3s. Now when we take a pair, they have to be the same number. We also have 1 pair of 2s. So the 2 and the 3 will come outside of the radical. Now this 2 that's left over here has to stay in the radical because it doesn't have a partner. So now that we have those outside, we can multiply those together to get our final answer of 2 times 3, which is 6, radical 2, which is radical 72 simplified. All right, so our second way to do this, the part B, is where we write 72 here with an upside down division. So to do this, it's like we're dividing, but we're going downward. And so the first thing, like we talked about earlier, is 72 can be divided by 2, and the answer would be 36. So we're going to write a 2 here, and the 36 goes here. And then we're going to break down 36, and it's just going to make a little train going down. So 36 divided by 2 is 18. Then we can break 18 down by 2 again. And so now we have the 3 2's. 18 divided by 2 gives me 9. And we break this 9 down. 9 divided by 3 gives me 3. And to make sure that we have only prime numbers, we can break this down one more time. Divide by 3, and we have 1, because we want 1 to be our last thing. So the same rule applies as before, that we're getting groups, we're getting pairs of numbers. And when we get the pairs of numbers, they have to be the same number. So we have the pair of 3s and the pair of 2s. Now, like we talked last time, these are the numbers that will be outside the radical. So we have a 2 and a 3, and this 2 over here that's by itself will go inside the radical, and this 1 will go inside the radical. So 2 times 3 is 6, and 2 times 1 is 2, so we get 6 radical 2 as our answer, just like the last one.